Hey gang, Mr. Cruze here with another Algebra 2 review for you. This time the Chapter 11 Part B test over sections 11.1, 11.6, 11.7, 11.9, and 11.10. Okay, this test will be Friday, May 17th, 2013. Again, as usual, you can always Twitter me if you have questions. You can post comments on this video. You can come in before or after school to get some extra help, alright? I want you to do as best on this test as you can. So, here we go. In how many ways can 4 tires be arranged on a car? Well, you're just kind of putting things in a line, right? If you think about a car, there are 4 tires. In the first spot, I could put all 4 tires. I could put any of the 4 there. But once I put 1 on that, there's only 3 left for the next one. And again, only 2. And finally, the last one only has 1. So one way you can think about this is 4 times 3 times 2 times 1, which is the same as 4 factorial, which is 24. There are 24 ways that those tires can be arranged on the car. The next one is simply a plug and chug exercise in your calculator. 9 permutation 6. Remember, permutation means order matters, right? So this is 60,480. Okay. 7C3, yet again, another plug it into your calculator exercise. You get 35. Piece of cake. Restaurant offers 8 appetizers and 11 entrees. How many different ways can we arrange the appetizers and entrees into meals? Well, since there are 8 appetizers, and any of those 8 could have 11 entrees. So you can think about appetizer 1, appetizer 2, appetizer 3, and so on. Every one of those 1 appetizers has, technically, 11, I'm not even going to draw all of them, 11 different entrees. Entree 1, entree 2, entree 3, and every single one of those has it. So a real simple way to figure this out is 8 times 11. You just multiply them. So there are actually 88 different ways you can arrange appetizers and entrees. Okay? Number 5, an ice cream shop offers 33 flavors of ice cream in how many ways can we choose 4 or 5 scoops? Well, does order really matter here? That's the big question. Remember that permutations, order matters. And with combination, does not matter. Order does not matter. Does it really technically matter what order they scoop the ice cream in? Technically, no. So that would be combinations. So I'm going to do 33 combination 4. But not only do I have to do 33 combination 4, I also have to do 33 combination 5, because they want 4 or 5 scoops. So I just plug those both in my calculator. 33 combination 4 is 40,920. 33 combination 5 is 237,336. So you add those two together, and you get a measly 278,256 different combinations to do 4 or 5 scoops of ice cream. Okay? Number 6, how many different teams of 11 players can be chosen from a soccer team of 16? Again, does order matter? Nope, because I'm just choosing 11 people out of 16, right? It doesn't matter technically what place they go to. So again, combinations. So you do 16 combination 11. And you type that in your calculator and you get 4,368. Okay. Now number 7 says how many different 9-player batting orders can be chosen from a baseball team of 16. Now notice, it even says batting order. So order does kind of matter here, and any baseball players should be able to tell you that. So this is permutations. We're going to do 16 because that's how many total there are. Permutation, well, how many are we picking? We're picking 9. So 16p9. Which is a really big number. I think it's 4,151,347,200. It's a lot of batting orders. Okay. Number 8, use the Binomial Theorem to find the third term of x minus 4y to the third. So we're going to think 2's here. And let me explain my rationale for this. Normally, if we think about the first term, it's n choose 0, a to the n minus 0, b to the 0. That would be the first term. When you get to the second term, you replace those zeros with 1s, right? And when you get to the third term, you're actually going to think 2's. These 1s become 2's. Okay? And then now you just have to plug things in. N happens to be 3, so we're going to do 3 combination 2. A is x to the 3 minus 2 power. B is negative 4y to the second. So anyway, I'm kind of writing backwards here. 3 combination 2 is 3. That'll be x to the first, and this will be negative 4y squared, which is actually positive 16y squared. Then you just have to multiply the number part. 3 times 16 is 48. We have an x to the first and a y to the second. So that will be 48x y squared. Binomial theorem to expand a minus 2b to the fourth. Okay. So this is kind of interesting. Anyway, the binomial theorem tells me to start off with n combination 0. So I'm going to do 4 combination 0. And it tells me to do a to the fourth power. Well, a is a, so that's kind of nice. Plus, we're going to do 4 combination 1. A comes down a power, so it'll be a to the third. It'll be whatever b is, which is the second part, negative 2b to the, well, we're going to kick that up a power. So that'll be to the first power. Plus 4 combination 2. Kick a down a power, bring the other part up a power. It's weird to call this a b because it has a negative 2b already in it, right? 4 combination 3. A goes down a power, a to the first. The b part goes to the third power now. And then 4 combination 4, finally the b is just all the way to its maximum power. Now we just have to figure all these out, right? 4 combination 0 is 1 a to the fourth, so it'll just be 1 a to the fourth. Plus, I can write the 1. 4 combination 1 is 4, that'll be a cubed times a negative 2b. Plus 4 combination 2. 4 combination 2 is 6. A squared negative 2b squared. 4 combination 3 is 4. A times negative 2b cubed. 4 combination 4 is 1 times negative 2b to the fourth. Okay. Now we just have to multiply all the numbers together. This is just 1a to the fourth, so that's easy. This one has a 4 times a negative 2, so that'll be negative 8a cubed b. Notice the a cubed and the b just stay the same. It's the number part we change. This time we have a negative 2 squared, so that'll be positive 4 times 6, which is 24a squared b squared. This last part, negative 2, or not last part, negative 2 cubed is negative 8 times 4 is negative 32ab cubed. And the last one, negative 2 to the fourth, is positive 16b to the fourth. There's your final answer. You will notice, it's because this was minus, starting with the positive term, every other term alternates signs. Okay, so be careful of that. Number 10, find the probability of 8 successes in 12 trials for the probability of success being 0.17 on each trial. Well, you'll remember the formula, n combination x, p to the x, q to the n minus x. So x is the number of successes, n is the number of trials. So we have 12 combination, we want 8 successes. P is 0.17 to the, well, how many successes do we want? We wanted 8. If P is 0.17, Q has to be 0.83 because they have to add to 1. And I'm going to have 4 failures. And really, you just have to plug this in your calculator. And if you're careful, you can do it in one step. 12 combination 8 times 0.17 to the 8 times 0.83 to the fourth. You multiply that by 100 to get your percent. This actually ends up being a pretty small percent. It actually ends up being 0.0, we'll go with 0.02%, that'll be fine. Even though it says nearest thousandth, I'm not going to worry too much about that tomorrow. It's mostly the work that I care about, okay? Number 11, a poll shows that 76% of voters in a city favor candidate A, so that's P. P is 0.76. If 8 voters selected at random, that's N. N is 8. What is probably exactly 5 of them? That's x equals 5. We'll vote in favor of candidate A. So 8 combination 5, probability of success to the number of successes, times probability of failure, which is 0.24, to the third power. Again, plug this in your calculator. 8 combination 5 times 0.76 to the 5 times 0.24 to the third. Multiply by 100 to get your percent, and you get 19.6%. Okay. I guess I'll do this last one really fast. 61% of the population swallows at least one spider per year. So that's P. Based on the study, what's probably more than 7 out of 10? So n is 10. Since it's asking for more than 7, x is 7, 8, 9, and 10. So you kind of have to do what we did here on numbers 10 and 11. You have to do it 4 times. You have to do it for 7, for 8, for 9, and for 10. So I'm going to get you set up here. 10 combination 7 times 0.61 to the 7 times 0.39 to the third. That gets you the first one. 10 combination 8, 0.61 to the 8, 0.39 squared. I'll give you the second one. You do the same for 9. That'll be to the first power. And then you do 10 combination 10, 0.61 to the 10, 0.39 to the 0. You get all 4 of these, and then you're going to add them. Okay? So, let me see here. I'm going to do this as quickly as I can. 10 combination 7 times 0.61 to the 7 times 0.39 to the third. For this one, I got 22.4%. You can check my work if you don't believe me. Change a couple numbers in my calculator here. This is where having one of the nice handy-dandy calculators that lets you see your what you typed in previously works out, because you can just change the numbers very easily that you typed in. This one's going to be 4.6%, so obviously it's going down, right? This one will be 0.61 to the 10, which is 0.7%. Anyway, add them all up. 22.4 plus 13.1 plus 4.6 plus 0.7. You get a total final percent of 40.8%. That 40.8%, the more than 7 of the 10 will have swallowed at least one spider in their sleep. Okay, kind of a morbid question, but that's fine. All right, if you have any further questions, comment on this video. You can always tweet me at Mr. Cruze Math. You can email me ccruze@brownsburg.k12.in.us. I'll be here after school. I will be here in the morning. Come and ask questions. I want you to do well on this test. All right? Make sure you put whatever you think will help you on your note card. All right? Good luck.